Okay. On Monday, is this working? Is that red means doesn't work? Okay. Okay, this is much better. Okay, on Monday, I show you the concept of a smart fridge and how do you from your own refrigerator, you can download information and then you can go to a grocery store and then purchase something. And during that process, you might receive a coupon that's based on some information. Um, the concept itself is pretty, I would say, it's pretty deep. It's not just about technology. It has a consideration about information privacy, about the situation which you consider is not just for a pure economic reason, but also consider people's behavior, such as somebody who is addicted to alcohol. That was the example I used. So it has a concern about ethics in the computation. I show you a program, and this directory I found out after I left here on Monday. I realized I messed up an older version of this program with the current version. I put it in the EE1520. So I made some update. So now at least it can compile. If you go to the directory, the repository. Let me see. Let me come back. Let me go to this. If you go to GitHub project base, I made some changes to some of the file. For example, I update the coupon a file, a bunch of file I have update and make file I update. So right now it can put together between the original code, which is the coupon and smart fridge part of the code, and together with the post, the Facebook part of the code. They're essentially follow a consistent style. So now if you download the whole thing, you can compile everything together. I mean, the issue I realize is between message and the person. So I would like to spend part of the time talk about this and talk about how do you write your project proposal. So when you come to my office to do your next the homework assignment grading, which is you can come to my office to do your homework two, and some of you homework one. Some of you haven't done your homework one. And also with your homework three, you can come to my office and then my server's there you can contact. So, and then at that time I will talk about, so the next phase when you make the appointment is going to be 1 hour. And then it's going to be your whole team come to together with everybody with me in 1 hour conversation. Okay, so let's actually take a look. First, I run the program. The program is called YSD Grocery. And it has a bunch of things. That's actually the end of the result is delivery of a coupon. Delivery of a coupon. You see that the coupon was delivered for either this is the diaper or this is the beer product. Okay, so that's with the correct UPC number, either it's a UPC 12, UPC 14. Okay, so let me go over the program a little bit closer so you will know what's going on. How do we do this, and how do you can use all this? Right now, there's lots of classes. Let me see if I can make it a little bit smaller so you can see the whole class that was defined in this directory. Okay, so we have a bunch of classes right now. So in object-oriented programming, if you want to develop a system from scratch, which means that you're going to build everything yourself, like what you did with the C programming language, then it will be pretty expensive because you have to do a lot of things and you have to do a lot of debugging. So in object-oriented programming, we always prefer reusing. I mean, reusing not only shortening your development time because you can just use an existing module with inheritance relationship to modify, to extend, and such that you can have something which is very close to what you want to have. And also the other thing, important thing about reusability is all this existing module has been tested by others. And it has probably been used in a lot of real world application. So therefore, is the chance that it will still have bugs is really small. Okay, by the way, when you use other person's code, even those code has been used a lot, it could still be possible that it has some bugs. And so that's kind of the curse about programmer. I gave you an example. If you're using a really popular Python library, I mean, this day, the most popular Python library is probably PyTorch, which is all the AI related programming. You're going to use PyTorch one way or the other. Well, however, PyTorch has been used extensively, but it might not have been tested on certain configuration of software and hardware, and therefore, or a certain version of Python. And therefore, there still be a very small but non-zero probability that when you want to use PyTorch to develop your program, and you have a bug, you cannot explain why your code will run into a problem. But it could well be that the PyTorch is itself has a problem. And usually the experience, my experience is that I will always test the same program on the most popular platform that can run PyTorch. I mean, just an example, and see if you still encounter the same problem. If you still encounter the same problem, then probably the problem is not due to PyTorch, it's going to be your own problem. However, if due to the hardware environment, you have a bug, and you test it between a reliable existing hardware platform versus a new hardware platform, such as, for example, AMD versus NVIDIA, and you see a difference there, then that's very interesting. That's probably not your problem, but due to the environmental discrimination issue. Okay. All right. So that's why we have all this HVAC. I mean, by the way, my code still have bug, and some of you already pointed out several very interesting bug, and I really appreciate. And when you're doing this, if you encounter any problem, it could well be the problem is within the code in front of you. Okay. Okay, let's take a look at what we have here in the grocery. So the application is called YSD Grocery. Okay, inside here, of course, we have exception handling, try block, and I create a bunch of person, Oracle, Trinity, and Agent Smith. And then we have a location and standard IP address. This, by the way, that's UC Davis IP address. And I have my own fridge. My fridge is in Davis, is GPS Davis. And see, right now I have my fridge. Where is my fridge? My fridge is a has a variable called history. So what is a history? History is you can see the way I define is a vector of transaction. So transaction meaning that, okay, I go to a refrigerator, what do I interact with the refrigerator? That's transaction. And you go to a bank, you interact with an ATM machine to deposit the money or to withdraw money. Each of those is a transaction. So transaction is a autonomous action between usually between a person and some kind of target, or maybe between two target, not even involve a person. That's called transaction. So if you think about your fridge, the way to abstract, by the way, the concept of transaction is very powerful in programming language. It allows us to think about a history about what happened to a particular object or a particular person or particular device. And the history about that device can manage a bunch of information that's actually going to be very useful. I give you an example. If you have a fridge and if you have the history of transaction and you are going to see your doctor next week to check your health, and the doctor will try to understand why your cholesterol suddenly increase a lot. I mean, why your blood situation or your blood pressure there's some significant change. A lot of those has to do your diet, how you eat food, how you purchase food, how much vegetable you have, how much hat, and how much bottle of beer you took. For example, ice cream versus healthier option. So how do I actually find out? I mean, it's very easy. You can actually check with your history about your fridge. I mean, by the way, I don't know if you realize your refrigerator represent a lot about what kind of food you have for not just for you, but for the whole family as well. So it's a source of information. That's why Google looked at this a few years ago. I don't know what's their situation, but that is essentially another very important source of information for us to understand. Okay, I mean, this is another thing which is very interesting. You can think about that for your final project. A lot of people talk about AI this day. They want to analyze the your health or analyze why certain people will have some certain health condition. Usually, we're looking at things like a correlation of data and causality about the data. But it's very important thing is you need to have the data. And without smart fridge, we do not have a very accurate information to actually understand. So that is the AI innovation ultimately is about whether you have the data that enable us to have the innovation. So I want you to think about this as a good example. Okay, so you can see that I have a history, which is represent the vector of transaction. So I want to actually talk about transaction itself. So over here, you see I have a transaction. The transaction, I have a few information. I have a transaction, I have a location about the fridge where, when, IP address, and what's the agent, means that which person involved this particular transaction. Okay, so you can see that this transaction I was defined pretty simple. It's just a location and the time and who is involved. Okay, but you can add those transactions to more things. For example, I want the transaction to be a food related transaction. Then that's going to be inheritance. You can have a new transaction that's related to deposit a food or consume the food. And then you can make the transaction much richer. But the concept of transaction define where, when, and the agent is represent the simplest common property related to this transaction object. Okay, so let's take a look at transaction as a class. Okay, here's a transaction. I have a bunch of stuff. I have the time, JV person, and relation, and OK. I declare transaction as a how do you define a person and a bunch of things that's happening. And then I have a transaction that has other related transaction. For example, if you a transaction involve how you access to a food item in your own refrigerator. But this particular food was involved another transaction because you purchased the food 10 days ago at a fridge that's in the grocery store, Chenlian. And therefore, you can actually connect those transactions together. So if you think about the design of the transaction, it helps us to trace what's the history about how a food is here and how does it being distributed, transport from location to location. In fact, if the grocery store do the same thing, you can even trace back. I mean, where did Chen Lian obtain this particular item? Is this from other location in Taiwan, or this is from some other international source? This is very important for the tracing about the food safety. For example, you want to know where the food is coming from, and then whether that particular location has a special disease and such that you can quickly understand that what kind of food need to be removed from your refrigerator. For example, there is an outbreak about a particular food disease in Europe, and immediately you need to know, go to your refrigerator and then realize that which of your food item in your fridge was was actually have a history transaction that matched the time for the outbreak of the food, and therefore you will be able to quickly remove that. By the way, this is also innovation, and by the way, the thing is that today we don't have a trace. You basically trust the store to protect you, and when you have a bunch of stuff in your refrigerator and you lost your control about which item is at the moment safe to consume. Okay, that's an example. I also want to tell you, of course, I have a dump to JSON. By the way, this is the prototype. So I didn't have JSON to object implement for transaction. But if you realize that you want to, it makes sense for you to have that, you can actually add it to that. Okay, which shouldn't be too hard. And then I have other kind of transaction, for example, flight. Okay, for example, a transaction could be a flight. I want to purchase a ticket, and therefore I want to have this is just show you an example. I could have a class called flight, which is a special kind of transaction using a single inheritance. And then the new attribute is I have a concept of passenger and the airline and the ticket number. Okay, so now you can see that with a concept transaction, you use inheritance and then you can extend it to other class. Okay, and then of course you can have lots of other function such as, okay, I can have a departure and arrival, GPS location and time. In fact, here I shouldn't use GPS DD. I should use the other class called time location. Timed location means that when you're here. So if I want to represent a flight, then this is not just a GPS DD. This should be time underscore location, which I can capture exactly what's the departure time and what's the arrival time for your flight. So just an example. Okay. Any question? Okay, so I create a bunch of transaction, and which means that I can have a bunch of transaction that's before I go to the shopping. So essentially what we want to do is that before you go to the shopping, you go to your refrigerator and you essentially download all the transaction to your phone. Okay, remember we say that this particular refrigerator is not accessible. So once you get into the grocery store, you already lost the contact with your refrigerator, and therefore you won't be able to get the information about your fridge. So you must download to your phone. And then now you go to the phone, then you interact with that. So this is the feature I mentioned last time called iLot. It's called Internet List of Things. So let me actually write it down here. This is based on the architecture of iLot. iLot stands for Internet List of Things. And why do we do this? This is kind of what I call the security while inconvenience. Okay, so this is a concept I think it's good for any system designer to understand the trade-off. A lot of cybersecurity bugs were introduced because we want to provide more convenience for the user. I mean, let me repeat that again. I mean, I know this is a programming class, but this is also a good opportunity for me to convey a few very critical cybersecurity concepts because that's my heart. So a lot of the security bugs were due to we want to have convenient access to the information or operation. And therefore, in order to fundamentally remove a lot of such security vulnerability is to introduce inconvenience. Okay, so the example I was using here is that when I go to the grocery store, Chenlian, I should not have a way to access the information of the fridge located in my home. Okay, so I'm inconvenienced myself. But the important thing is because I inconvenience myself, I also inconvenience pretty much everybody else in the whole world, including those hackers who like to get into my kitchen and try to get my important information from my appliance in my home. This is the concept of smart home. Okay, so that's the idea. However, the reason I can do security via inconvenience is because that's my home. So I have the very easy way for me to physical access the fridge. That's why the opportunity, the differentiation between me and the rest of the world is that I have the key to go to my refrigerator, but nobody else can do that. Okay, so that's the design, fundamental design. You should think about that. We should not put everything on the internet by default. Okay, so this is the idea. So before I go to the grocery store, I'm going to put all the transaction, meaning that I'm actually downloading all my fridge history to my phone. So now I have that, and also I can define who actually can access my fridge. This basically say, hey, I might not want everybody access my fridge. I want the me and my roommate. Just in your case, you sometime might host some party, and suddenly you have lots of people, random people come to your home, and then use your refrigerator. And then when you have a fridge, you should have a way to define who can actually access your fridge, which means that who can access your fridge, but more important, who can access the information, the history about your fridge. Okay, and that's important. That's fundamental privacy issue. Okay, then we actually have a grocery. I call it Nugget because that was I don't know if you know, Nugget was one of the major grocery store in the city I used to live. Okay, and so I create a market called, I create a grocery called Nugget. And inside the grocery, I also has a fridge. I call it Nugget fridge. Okay, so inside over there, I also have that. And then I can start to put in the product. Each of the product can go to that particular grocery store. Okay, so let's take a look grocery. I thought my grocery is very simple because I don't think I actually implement that part. Okay, so the grocery is a inherit from a concept called space. And inside this space, essentially, I have a section, I call it a map, a storage, a string and the storage. So this is the first time you probably saw this. You have seen me using doing something called vector. Let me actually show you this. This is a good opportunity for me to talk about this. See, not okay. Here is a good one. So it's good for me to now take a chance to move into this topic called class template. Wait a minute. So now we are going to talk a little bit about class template. So template is an idea is that we found in our code. There are so many places, they kind of repeat each other. They're very similar. So instead of writing every time the same code again and again, we create something called template such that we can parameterize the template such that it can automatically configure itself to be very useful in other cases. So one of the things, before I tell you how to do a class template, I will tell you how to do function template today, hopefully the second lecture. But there are a bunch of what we call standard template library. Standard template library. And here is essentially all the standard template library. Let me move it out. Okay. Wait a minute. Am I still on the network? Ah, it looks to me I'm still, wait a minute, I'm not on the network anymore. Is that right? Per second. Okay, that's good. I have recovered the internet. Okay, that's great. Okay, so in the this is pretty much the most commonly used STL, standard template library. So far in this quarter, this semester, I keep forgetting that. We have been using vector. Vector is equivalent to an array in C programming language. And over here, there is a bunch of kind of like a logic. I mean, what kind of template you like to use? I know the font is really small. It's telling you a bunch of questions. You could have a template called stack, and you can have a template called queue. You can have another template called priority queue. And over here, you have a template called list, you have a template called vector, you have a template, I cannot even see this. It's probably, what's this? Wow, I cannot even see it myself from the screen. Let me actually take a look. This one is DQ. Okay, that is a list, vector, and the DQ. And over here, you can have a template called map, which we're going to talk about this, and set. And then you have another kind of map and the set. So you can see that there is a bunch of data structure for you to be able to represent things very easily. Okay, so I'm going to talk about, let me use this one. I'm going to talk about map. So I assume you're probably already familiar with a vector. A vector is essentially an array. So you have, if this is not a map, this is an array, then essentially you have the name of the array, name of the vector, and you put an integer between this bracket. And then that's going to help you to index. This is called index for you to obtain the content or the object being stored in that vector or in that array. So in that case, that this is a name of the vector, the index itself, and the identifier to the object. Okay, that's the way you access vector. But then the difference between map, the other one, map, is really useful. You guys already use JSON. Essentially, JSON use map a lot. So what is JSON? Or what is map? Map is you have the name of the map, and then the index, instead of an integer, you're going to put a string. So it's from a string, then you identify to your content, which is your object. This is called map. So why they call map, I don't know. But to me, a map is just like a JSON. It's just using a key. To me, it's a key value pair. So you can see that sometimes we call it map, sometimes we call it key value pair, sometimes we call it JSON. They're all pretty much the same. But it has a function. For example, you want to know, for example, in the vector, even in the array, how do you know how large is array? I mean, what's the range of index? You usually can use the size of the array to actually check on that. But in the map, the way it do is using find. So you can do postmap dot find a particular key. If they have the key, then it's going to return you that content. So postmap dot find whatever key. If they can find it, then they will return the post pointer, which is the content stored in that particular location. But if it doesn't have that key, then essentially it will be equivalent to postmap.end. This. So this is the special function for for map, such that when you call end, that means if you cannot find it, then essentially the return of this find is going to be equal to the end. In that case, you know this key doesn't exist in this map. So that's the concept about map. So let me take a look at the real example. So map is quite useful. As long as you can identify a particular object using a string, which is pretty much everything, you can do that. And you use that key to insert an element to the map. Then essentially you can use the same key to retrieve that. Okay, this is, if you think about a search engine, by the way, I should now talk about the idea of a search engine. If you think about search engine, how do you search a particular object? Then using map is a really good one, right? I mean, you just need to remember what was the key associated with the item you would like to search. Then essentially map allow you to do a basic search mechanism. Of course, this is not good enough. In the real commercial grade search engine, you need to be able to do much, much better than exact key match. I mean, to start it with, which is not very innovative, I mean, at least you can see if your spelling about that key is close enough, then I should help you to actually correct your spelling and find the right item for that. Okay, so that's the idea. So I just show you two things. One is, what is STL, Standard Template Library, meaning that you have a bunch of things like a vector, like a map, which is commonly used. And the way you will see whenever it's template, it has this special way of representing that. And then you can know what's how to use that. And once you have the map, this is the syntax for you to use the map. Either retrieve a particular item, or sorry, this one is when you insert an item. The first one is insert. The second one is retrieve. Okay, that's insert and retrieve. Okay, let's take a look at the example. So let's look at the grocery. The grocery, I'm using the map. Okay, let me parse this a little bit. Don't look at, let me actually take a look at the whole thing. Just look at this part first. Look at this part. This part is the declaration about the map. And then this part is the identify the name of the map, but the name of map is a pointer. So this one, the way I read it is, let me actually do this, because I know for some of us, we're not familiar with the pointer, so sometimes we will get confused. So let me go do this. You see, I mean, I like my editor because it knows how to separate information. It knows that this part is the type declaration. This is just a pointer, and this is the identifier about the things. Okay, so let me actually tell you how do you parse this. This is declare a map. And then you have a pointer. And then what is section? Section is a pointer to a map of a map accessing a pointer to a storage object. Okay, the last part may be complicated because the first part is just a session. Session is a pointer to something. And that something is a map accessing a pointer to a storage object. So I want to parse this part further because this part itself is complicated. So I'm going to parsing this part. Parsing meaning that how do I read this appropriately? So first, you have to know there is a template. Which part is a template? The template is this part. This is a template. If you remove the std string and the storage star, that is a template. Okay, that is a template. And this template take two arguments. The first argument, I will call it, the first argument is the data type of the key. And the second one is data type of the object. All right, so this is the way you define a template. So in this case, what is my key? The data type of my key is std string. And what's the data type of my object or content of the map is storage star, which is a pointer to a storage object. Storage, which is a pointer to a storage object. Okay, I hope this helped you a little bit to understand the map. How do you parse the map? You have to know that Okay. Whenever you see in C++, whenever I should actually say this, whenever you see a pair of smaller than and greater than sign, then that is a template of something. That is a template of something. So whenever you saw that, you know it's a template. So which means that this template called STD map, it can use for a lot of things. I mean, for example, in this case, I was using the key is a string, but my content, the object is a storage pointer. I can actually make it, oh boy. Do I have another, this one is not working anymore?
Should do the better.
All right, sorry.
No. It's not working too.
Okay, fine. That's okay. I will just speak louder. I hope you can hear me from the back. So let me give you other example. I can do a map, which is, let me change this one. I can change the map to be, let's not do a string. I can do a GPS, DD, and over here is JSON value. I can create a map, looks like this. And this is essentially saying that the key is a GPS location. And then the content is a JSON. Or I can do this as well. I can do another example, which I can say the map is JV time. And the key is a transaction. So which means the key is a particular timestamp. And then the content is going to be a particular transaction as we talked earlier. I mean, what did you do at that time? Okay, you can see that it's pretty flexible that you have a one single interface called map, and you can define what should be the data type of the key and what should be the data type about the JSON value. So now we're going to go back to this particular example in the grocery.h. The way I define here might not be the best way. I'm actually defining each of the sections. Section means that, okay, I have a bunch of sections. This section is about this type of food, and this is for the other type of food. Is this working? Okay. Thank you. Okay. Now I think we have the idea. So once you have the map, then essentially you can allow the grocery, when you enter the grocery, you can go to each of the section. And what you have in each of the section is a storage. So let's actually take a look at the storage. By the way, grocery is type of place. Okay, so now let's go to grocery. Go to storage. I want to say something. By the way, before I do storage, I want to do, let me see, more fridge. By the way, the fridge is also a storage. Okay, so the grocery has something. So essentially what grocery has a bunch of storage, but it's a general type for fridge because some of the section in grocery store, they might not be fridge. They might be just a regular shelf to put in your food item or whatever the other item you would like to sell. Okay. So now let's take a look at the storage. So a storage that inherit from Target, but there is something which is quite interesting. It has a item and has a storage. I actually declare here. I want you to think about over the break, why do I need to put these two lines over here? Okay. And you can see that the storage is public, and then each of the storage, they have now I have a bunch of vector. I have a lots of content that's actually over here, and the storage is essentially handling, okay, who have access, that's also controlled by the storage. Okay, so I'm going to pause here for you to think about. One of the questions I want you to think about first, of course, try to understand what I did earlier. But the other thing is I want you to know is this question is, why do I have these two lines over here for the code storage?